Welcome back to Organic Chemistry. Today a little bit about redox reactions in organic chemistry. So if we imagine the chemicals that we already know of, we can think of a series. So if we think of an alcohol, so a primary alcohol, that would be the first member of our series. It's not actually the first member, but let's think of it as that. Let's oxidize it up one. So if we oxidize a primary alcohol, we can form the aldehyde. That's not a very good pen. Let's get a blue one. And if we oxidize our aldehyde, we can form the alcohol of the acid. Tidying that up and putting it the other way up so that we've got more oxidized at the top, because that seems to make more logical sense, we get the following. I think I missed all of that, so let's try again. Looking at this oxidation ladder, we can imagine our normal primary alcohol here to be oxidizable to an aldehyde. So if this was ethanol, this would be ethanal, and then we can oxidize the aldehyde to the acid. If we look at the effect of doing that, we're removing H2, we're removing this hydrogen and one off the carbon, generating the aldehyde, and here we're adding an oxygen in between the carbon and the hydrogen. If we take it one step more on the reduction side, we can reduce this alcohol to the alkane by removing an oxygen. This is a relatively standard series in organic chemistry. We can see if it's a secondary alcohol, we get stuck at the ketone because we can't get any further, not normally anyway. We would break the backbone of our molecule if we did that, so we end up with completely different components. If we reduce it, we get down to the alkane just the same way. This is useful. We can look at these reactions because this is fairly normal, so we know from normal home experience that if we take alcohol and we leave it out, it goes sour because it oxidizes in the air and becomes ethanoic acid, vinegar. We can also get it to go up to the aldehyde, which we know if we go out drinking. Because if we go out drinking, what we discover is we feel good while we're drinking, and then the next day we don't feel very good. And the not feeling very good is this compound, the ethanal, which is busily poisoning us. Exactly the same happens if we drink methanol. Don't do that. If we drink methanol, the methanol is reasonably poisonous, but not super bad. The methanol, however, is extremely toxic, and that's what kills people. The medical response to somebody poisoning themselves with methanol or accidental methanol poisoning is giving you lots of ethanol, which then distracts the body and makes ethanal instead of methanol, and that's not quite as poisonous. Neither of which is a good idea because methanol is bad in all kinds of other ways. If we take this row though, we can think of it in another way, because we've got this step and this step on this side where we're removing hydrogen, or we're adding hydrogen the other way, so H2. That is reasonable. It seems quite normal from a oxidation reduction system, which we either add an oxygen or we remove a hydrogen. That makes sense. But then that suggests to us that there should be, or could be, another set in between that I'm about to draw. So if we take our carbon chain, our hydrocarbon, and we remove two hydrogens, then we can imagine that it will also do a thing. And so instead of forming an alcohol, removing two hydrogens makes a double bond. Remove a hydrogen from this carbon, remove a hydrogen from this carbon, hydrogen leaves, we generate a bond. In fact, we know this from margarine manufacture, that we would try to add hydrogen across a double bond to make margarine instead of oil. So this process is known as a known industrial process. This process, on the other hand, is a reduction, and now we know that it's a reduction because it behaves exactly the same as this one. Okay, I've forgotten where I am. So this row is an alkane row, where instead of adding oxygen, removing hydrogen, adding oxygen, we are just removing hydrogen. And in exactly the same way, we're doing an oxidation at every step. So we're oxidizing our alkane to form an alkene, and we oxidize our alkene to form an alkyne.